Hello to everyone and welcome to our cloud coaching session. Today we talk about an overview of the AI infra monitoring available in OCI. We have the pleasure to have Karthic Ravindran, who is coming from the OCI Observability and Monitoring team in Oracle EMEA, and he will share with you a lot of hints and tips regarding how to monitor and save your costs in case you use AI services. And of course, everything will be demoed in the Cloud Console. So if you have an Oracle account created, feel free to take this journey together with us. All right, that was all on my side. Karthik, over to you.
Thank you, Violeta.
You're welcome.
Hi, everyone. Thanks for joining today. So the topic is overview of AI infra monitoring in OCI. Okay. So if you are the person who already uses GPU and already using a monitoring tool and you know everything in and out, this session is not for you. Okay. So to be clear and don't want to waste your time, right? And if you are new to GPU and knew how AI infra is built and why GPU is used, and you want to know what are the metrics you want to collect in GPU, then this session is for you. Okay. Yeah. And there is no slides. I'll directly do demonstration. I'll just give some overview in the first 5 minutes, and then I will show you how you can monitor your GPU using Prometheus Grafana open source tool, and also how you can do the same in OCI native tools. Okay. So coming to GPU, why GPU is used in AI infra? Because of the parallel processing, GPU is mostly used in AI. And in the GPU market, NVIDIA is the market leader. So if you see GPU either in your on-premise or in other cloud vendors, mostly you will see NVIDIA GPUs will be there. There are AMD in the market as well, but the NVIDIA is the leading one in the GPU era. Okay. So when you start using GPU for your AI, it could be your training model or it could be your production deployment. There are some metrics you need to watch out for to know whether your GPU is performing well. In case if you are using your on-premise GPU, okay, or your cloud GPU, you have to watch out for metrics like your power usage, your temperature of your GPU, and the memory allocation for it. Why is it needed? If the metrics, these are the important metrics in GPU, if these are not monitored, sometime like if your power or temperature is shooting up, every NVIDIA GPU devices will have a limit for the temperature, which says that this is the optimal temperature range, which works perfectly for that particular hardware. Okay, so that is important. The another thing why we have to monitor those metrics is you have some AI model deployed, but you are not utilizing your GPU to the utmost capacity, then you are wasting some of the resources. So these are the important reasons why we need to monitor our GPU. And also, there are other reasons. When I say monitoring, that you also need to know that in cloud, especially in OCI, if you give permission for everyone in your team, they should not launch any of the GPU because it's so costly. You should not allow the persons to launch it unless they are authorized to. And we will see like how you can alert if someone launches a GPU or how you can restrict it. And also we see the monitoring metrics using Prometheus and also the same in OCI monitoring tools. So this is the dashboard which Prometheus or Grafana has been given you for you. Okay, how these metrics are coming up, I'll just explain it. And I will tell you what are the tools mostly people use for GPU monitoring. Okay. In general, there is a tool called NVIDIA SMI, which is available in the NVIDIA driver as part of it. Okay, so that's the most common tool people use to monitor their NVIDIA and GPU metrics. So you run the command NVIDIA SMI, and you will know metrics like power, CPU utilization of your power usage, temperature, and also how much memory and what are the process it's been using the GPU. Okay, and there are other tools like normal Linux tools like GPU stat, NVTop. These are other tools which you can install and monitor it. So there may be a question comes like, I have my operating system tools. Why do I need to use a Prometheus or Grafana or else the OCI monitoring tools? The answer is you can run your OS command tools to see the current metrics or statistics. But most of the time, we need to see the historical data. So if you want to see the historical data, you need to store the previous metrics in some place. So coming to the point now for Prometheus, the default storage is 15 days. So if you want to store more, you need to increase the retention period, how long you want to see, and you can keep it. So what's the problem with increasing it? If you see in the Prometheus, Prometheus stores the time series database on the system. So if you increase the retention, the storage used from your system will also increase. Okay. You have to be careful on that side. If you don't want to use a storage on your system, then there should be another reason or to keep it under the 15 days retention. Okay. And with the Prometheus Grafana dashboard, you don't need to build it. You can directly take it from the community. Okay. And when you need to use Prometheus and Grafana versus the OCI monitoring tool, okay, you can use this open source tool if you have a requirement that you have designed your model, but you don't know the choice that which vendor to choose or want to do it in the on-premise GPU. Okay, so you can run your same model in a couple of vendors, cloud vendors, and see the usage or your monitoring metrics and compare like which vendor is good for your models. Okay, so that's when you can use the open source tools to see like a multi-cloud or multi-hybrid monitoring. You can do it easily. Okay, it doesn't mean that you cannot monitor your on-premise or other vendor using OCI monitoring tool, but it is easy if you're using the Prometheus one to directly see it. Okay, so now I will show you the NVIDIA SMI and show you what it gives you. I have launched an instance of Shape VM GPU 810. So this uses NVIDIA 810 model. Okay, and I don't have any process which is using the GPU now. You can see clearly that there is no running process. The temperature is 26 degrees Celsius and the power is 15 watt and the memory is not used. Okay. And there are other tools, like I said, GPU stat. If you run this, you will get like this. You can get metrics in a one-liner, but I think you'll get more details with the NVIDIA, which is most commonly used tool now. But like I said, you cannot see the previous metrics. Like 2 days before, how it was performing for my model, you can't see it. So what I'm going to do is, I'm going to stress this system. Okay, I have just written a script using the torch. So mostly people use PyTorch or TensorFlow for creating their model. So just looping through some random numbers and just looping through it. It's pretty simple. Since I have only one GPU, so I'm putting the load on that single GPU. Okay. So I'm hitting a load now, and I'll show you the NVIDIA SMA command. So what you are getting it now. So you can see a spike in the power, like it's 53 watts now. You can see the memory is utilized now, and the process is, this is a Python 3 process which I'm running now. Okay. So now moving on to the dashboard. So by default, I have set the scraping interval as 30 seconds in Prometheus scraping. You can increase it or decrease it based on your requirement. And you need, whenever you set the scraping interval, don't set too low like 10 seconds or 5 seconds, unless it is for application metrics. If you're monitoring your infrastructure metrics, it's okay to set like that's the 1 minute is this a standard suggestion, but you can keep it for 30 seconds if needed, so that the metrics is so important that you want to monitor second level granularity. Okay. So now this dashboard is showing me, okay, I will do a refresh. And since there is a utilization, the auto refresh is already there. So once it starts shooting up, you should see a spike here. Okay. So this is what you see in the Grafana. And I'm talking about OCI monitoring tool. Can I see a similar graph using OCI monitoring tools and the dashboard? Yes, we can. And you can see the spike now. Okay. So the load, it's already spiked. If you're using the NVIDIA command, you will directly see that spike immediately. But we never know when we need to run it. So, and we're not there in front of the system always, right? So now I can see a spike. So which is like from 15 watt, it went to 54 watt of power usage. If your temperature is increasing and the power is increasing without any memory or clock usage, so you can see a memory utilization is there. That means there could be some problem in the hardware. If you are using in the on-premise that your fan cooling is not proper, then the temperature might spike. So in generally, if the power temperature is high and you also have a memory utilization high, that means your application is using it properly. And there is something called SM, which is stream multiprocessor, which where the clocks or the compute processing will be running on your GPU. Okay. Ideally, it will be 0 if nothing is used, and then it will start using the clock speed. Okay. Since we have only one GPU, it shows the GPU 0. If you are using multi GPU model like A100, then you can see multiple GPU model metrics here. Okay. And what I'm going to show you is now the OCI metrics. Okay. So like I show you that this is the instance which I'm running, a shape of A10, and I'm running a Grafana instance as well to see it. So with this model or with this type, you need to run Grafana on a separate machine. Mostly we don't run Grafana on the same GPU machine. So you need to have a Grafana on another machine, or you can use a cloud Grafana as well if you're purchased it. Okay. And I have this AA. And now the same dashboard, what you have seen in Prometheus, I have created similar stuff in OCI monitoring as well. How these dashboards are coming in and how the dashboard you got in Prometheus, both the metrics are coming from DGGM exporter. So that's the exporter given by NVIDIA, which collects all the GPU metrics which I mentioned before, like power, CPU, your SM clock metrics. If there is any CICD errors because of the hardware failure or your application failure, it will give those details. Okay. So we have just grabbed the main metrics here like power, SM clock, and the temperature. In the Prometheus, you have seen these 4 metrics, but I have added few more metrics, which is memory, CPU utilization, file system utilization, and the boot volume metrics, and also the logs. So what it's doing is the default metrics of GPU is coming up, and we also get these 3 metrics, which is coming from the stack monitoring. Okay. So I have the agent installed. I'll come back how the agent is installed and what are the configuration done, but these are coming from stack monitoring service for you. So these are widgets are already there. You can just drag and drop and build the dashboard. And most of the time, when we use our GPU in Oracle Cloud or any other cloud, you will also use the block storage or file storage to have your extra storage availability. So you also want to note the performance of the block storage or file storage. So in OCI, we provide the block storage metrics. I just mentioned this read throughput, but what are the other metrics you have it for your block volume or your file storage volume? You can see it in the dashboard as well. These are related to the metrics. And I have added a sample logs as well to show you it's not only the metrics, which might be important when we are monitoring our infrastructure for our AI, or it could be any other infrastructure. In this case, I'm monitoring the logs or the secure logs of Linux to know who is logging in, or is there any problem with the security of my instance because of the login and logout. Okay. So with this one, I'll be able to know who is logging in and stuff like that with the logs. This doesn't mean we can only see these logs. You can always add your application logs from your model is emitting any logs, and that is important for to note down like how you are training the model. Like if I pass like 10,000 data, how my predictability is there. You can output to a data table or some file, and you can see it here as well as a visualization. Okay. So with this kind of a dashboard, we can monitor the infrastructure as well as the application log metric. I'm not covering APM, which is used for distributed tracing in this session. If needed or interested, I will do another session on that topic. Okay. So what's the advantage of having this versus the Prometheus and Grafana? Like I mentioned, you need to have a separate Grafana instance, and by default, the Prometheus stores for 15 days. But with this one, I can see 90 days of historical data without you having to store the data on your machine. Okay, it's all as part of the service provider. And also, you can see the graph and other thing. Stack monitoring also provides you anomaly detection for these metrics like memory, CPU utilization. For the custom metrics, the anomaly is not available as of now. Okay, just for information. So how these are coming up, I'll show you the setup now. So I'm running a Docker container for the DGGM. Okay, I can grab for NVIDIA. So I'm running this exporter. This is the one which is emitting the GPU metrics, what we are seeing there. Okay. And if I run the curl command, I can see that also. Sec. Yeah. Okay. I think it's running on a different instance, so that's why it's not running on the local host. 1 minute. So, yeah, you can see the metrics. So this is emitting in Prometheus format. That's why we can see directly in our Grafana. Okay. And I also have a Prometheus running on the same instance, which is again running as a container. Okay. And what I do, the extra step to get these metrics are the agent is installed. By default, for GPU shapes, the plugin won't be available. You need to install an agent. The agent is installed. Okay, the same step like how you do for other CPU instances. The management agent can be chosen, depends on your operating system. Is it Windows or Linux based? Okay. Once you install the agent, we will set up the Prometheus emitter. And I'll show you the agent now. It's there in the path, port, Oracle, mgmt agent. Okay, I have to switch to sudo. It's in the path. Okay. It will be in the discovery, and then there will be a call Prometheus emitter. So there is a Prometheus emitter support for the agents. What it means is you can get the Prometheus metrics into the OCI monitoring tool. Okay. So I have a property files called DGGM properties. It could be any name dot properties. Inside that, you will mention where it needs to send or which namespace the metrics has to be sent, how long you want to collect. There is a parameter called schedule interval. The minimum is 1 minute. You can set a schedule interval 1 minute so that it collects the metrics every 1 minute. Okay. So I'll show you the metric explorer now. So this is the metric explorer where you can see all the metrics available for this namespace. So I'm sending all the metrics to this namespace called GPU monitoring. You can mention the namespace and it will get auto-created automatically for you once the policy is there. And you can see all the metrics which are available for us from the exporter. And in this case, I just show you about the temperature. You can always see the mean, rate, sum, what are the details you want to see, you can see it. And you have the dimensions like which model details you want to see. In this case, since we are using A10, it's going for the A10. We have only one GPU. That's why it's mentioned as 0. And you can choose the other device names or node name, etc. I can click on it and you can see the chart for it. Okay. Since there is a spike for us, so I have started a load. Again, there is a spike. Okay. So it's easy to monitor it. And I also mentioned about you monitoring when someone launches a GPU. Okay. So how you can monitor it is you can create an event rule for any of the instant launches. So particularly for GPU that you don't want any of your teammate unnecessarily creating a GPU. So create an event rule so that you monitor the launch of that instances as well. Okay. So I'll quickly show you that event rule. So I've just mentioned as GPU launch. Okay. It could be for any of the compute launch. Okay. This is important, like I mentioned, this is not for monitoring purpose, but it is important that if someone launches GPU just for testing purpose without the admin knowing it, okay? Because GPU is costly compared to CPU, so you need to keep this under control as well. This is one way, and also you can mention quotas so that no one can create more than the allocated quotas. And also using policies, you can restrict the users so they cannot even launch the compute instances. So depending on which method is useful for your team, you can use any of the methods. Okay. So yeah, I'll switch back. And this is the agent. And you can check for agents or downloads in the search bar. It will take you to the agent page. And it available as zip or as well as the RPM. Depends on your operating system and the architecture. you can download it and install on the system. What I do is like I will download it and it will put in my object storage. So whenever I launch my instance, I will set in the cloud init script itself that this will be downloaded, and what are the things or the steps I want to do it, I will do it in the cloud init steps itself while launching the instance. You could do it while through the cloud init, or you could do it through Terraform scripts, or if you want to do it later, once the instance is launched, you can do it as well. Okay. Yeah. So this is the important point here, like why you need to monitor and is it important or not, right? Even though the metrics are simple, it's clear that if you don't monitor it, you don't know whether it's been fully utilized it or not. Okay. So this is the main fundamental thing I want to convey today. And like I said, I have collected only one logs, but there are some debugger tools available for your models. If you want to send the logs to a particular path, and you can monitor it as well. Okay. And one more information, like you can see a gauge here, and there may be a question comes like, why can we have a gauge like in our dashboard as well? Okay. So we can create a circular format with JSON editor. It's in the advanced mode of the dashboard. And there is some work in progress so that we can get a similar kind of gauge as well. Okay. Just find the information. Yeah. So I will move to the instance now and see it's still my load is running. Okay. I think my M typo is running. I think we can still see this is running and it still utilizes the memory, and I will kill this process now. Okay. Yeah, we have killed this process. So we should see a drop in the graph. Okay. And immediately we can see from 58 power usage, it came to 22, and there is no memory utilization. So this is what I mean, that if you see a power usage and there is no increase in memory, that means something could be a problem in the hardware. Okay. And if you see a simultaneous increase in both the power and the memory, that means it is using because of the application. Okay. And switching to the dashboard, and you can see the same time, like how you can see the increase it, like at 248 today, there was an increase. We have only one GPU, that's why it's showing as NVIDIA GPU, and there is a spike till 57. And after some time, like after a 1 minute interval, we should see a drop in the temperature and the power usage. Okay. And this is the read throughput of the boot volume metrics. And since we are using it at this time because of the load, there is a spike on the boot volume read throughput as well. And I will switch to the NVIDIA, Prometheus metrics as well, where you can see slowly there is a drop in it. From 58, it's coming to 58, and then after some time, we should see a drop. Like I said, it will take a little bit of time because of the interval, 30-second interval or the 1 minute scraping interval. It will take a little bit of time compared to the operating system command that we run directly over there. Okay. And another thing, just for information, is I see some differences when we run other tools like GPU stat. Okay, I'll show you here. If you run GPU stat, you see this temperature as 29 degrees Celsius and 460 for memory. So if you are using other tools, please keep this in mind, that stick with this NVIDIA SMA, which is the local tool for your GPU, which gives more accurate information rather than other tools. Okay, so compare with NVIDIA SMA to see whether you are getting the same details as NVIDIA SMA. If it is not, so you should make sure that you're not using that for your monitoring metrics. Okay. Yeah. So I think I will stop here now.
If no further questions, thank you all for joining us today. Enjoy this great period with your families and friends. And of course, we hope to see you soon in January. Thank you, Karthik, for being here. Thank you, Ettore, Tom. See you guys soon. Bye-bye.